Comparing linear and exponential growth. Linear has the form y equals mx plus b, where exponential has a form c times a raised to the power of x. The dependent variable for both of them is going to be y, the output. The y-intercept or start value for linear is b. In exponential, the y-intercept or start value, initial value, is c. Those are both going to show up on the y-axis. In linear, steepness is defined by slope. The bigger the number, the steeper the graph. And in exponential, the steepness is going to be defined by a. The independent variable is x in both situations. The graph of a line, linear function, the graph of an exponential function is kind of a J curve. The operation in linear, you have this thing which is constant addition. You're adding the same amount. And here, in this one, you have a constant amount, but you are multiplying. You still have that constant amount, but you are multiplying, and in linear, you are adding. So taking a look at these two models, if I'm looking for linear, I'm looking for a difference. If I subtract each time in the linear model, notice between consecutive terms, I get a difference of 200. So the constant amount I'm adding each time is 200. So if I was to take 5,200 minus 5,000, I would get this constant amount every time between consecutive years of 200. That's my slope. If I'm looking at the exponential model, it's not going to be added, it's a ratio. So it's going to be this division multiplication instead of this addition subtraction. To show the ratio, again, you take two consecutive terms, and I'm going to take and divide them. 5,250 divided by 5,000. Showing that on the calculator, 5,250 divided by 5,000 gives me this constant multiplier of 1.05. Let's try the next two consecutive terms. If I take 5,512 and divide that by 5,250, notice my constant multiplier, it's rounded a little bit, but my constant multiplier here is the value 1.05. So when I look at an exponential graph versus a linear graph, linear, I might start way up here and have a very steep slope to it. So it's rising quickly. Regardless, exponential will always overtake a linear. Maybe my exponential started way down here, but eventually it's going to overtake that linear because multiplication builds much faster than addition. Exponential multiplication builds much faster than linear, which is addition. So what really happens with exponential growth? Maybe we might be looking at a deer population. We think it's growing exponentially because they keep multiplying, but eventually they're going to level out. That's called a sigmoid curve. And why would they level off? Well, food supply, predator-prey type situation.